Okay, see you again in this video. Today we are going to discuss about the problems that we have here. It's about machine. The load in the bucket of a sand loader is about 3 kilonewtons and its center of gravity is located at G. For the position shown here in the figure 1, we need to determine the forces in the hydraulics AC and DE. Yeah. And state whether they are in tension or compression. And we need to neglect the weight of the individual members. So basically, it's just the weight of the sand. So when you see this kind of problem, first what you need to understand is the load transfer. Try to look at the bucket and how the load transfer to the structure in general, right? Something like this. And here at point F, they should have Fx and Fy, right? And then here, since this is hydraulic, so two force member, right? You can call it FDE, yeah, the force in the DE directions. And then for the bucket, you can draw simple thing like this, right? Let's call it a hydraulic. And this is a G that has a weight of 3000 kilonewton, right? And we have all the dimensions. Yeah, so I'm sorry, this is not a good hydraulic, but assume this is the hydraulic. Yeah, and you have three unknowns if you evaluate this sand loader as a whole: Fx, Fy, Fde, and then you have 3000. So basically you can find Fde, Fx, and Fy, and then you can get the answer of one of the question, right? The force in the cylinder DE. So let's calculate. Yeah, if you analyze this, you can take the moment at F, yeah, sigma moment at F equals 0, and then the Fe will create. So this will create with respect to this, yeah, counterclockwise, right? So it's positive FDE times the distance of this loading with this center of moment, which is 750 in this case, right? So it's 750. And then is there any load? Yeah, this is also the loads that we have here. This will generate the moment too, but the moment will be also counterclockwise plus 3000 times the distance. What is the distance from here to here? 1500, 600, 600. So 1200, 2700, yeah. 2700 equals 0. Okay, so it's pretty straightforward actually. Okay, so equals 0. So so it's 3. Sorry. This should be, to make it easy, it's 3 kilonewton. Yeah, so let's call it 3. Yeah. So should it's 250, right? So your FDE will becomes 2700 divided by 250. Am I right? Okay, and this is in kilonewton. And then you get the first results that you want to find. Okay, and if you see here, it's negative because we assume it's out of from the point, so it's always tension, means this one is in compression. Or if you want to draw it, you can draw here the cylinder. So this FDE is negative, means that here it's like this, means it's like this, it's like this. So with respect to the hydraulic, it is in compression, and then later in the wall it should behave like this, right? With the same force FDE, right? Okay, I hope it's clear. It's pretty simple for this one. And then the next question is AC. So take a look at this AC. Yeah, so if you evaluate these things, let's draw it like this. Yeah, here you have Fx, Fy, which you can find from the previous one. If you solve sigma Fy equals 0, sigma Fx equals 0, you can find it. Then you have FDE, right, which is already obtained here. And here you have bx, and you also have by, and then you have this is also two force member, right? FCA. So there are a lot of things to account here. You need to find fx fy first, and then bx by, and then you can get the FCA. So I think it's better to analyze the bucket. All right, the bucket is like this, like this, like this, like this, like this, like this. Okay, and then here you have FCA, right? And then at point B, you have BX, and then you have BY, and then at point G, you have a load which is 3 kilonewton, right? 3 kilonewton. And then how to solve for the FCA? Yeah, because you're asked to determine the force in cylinder AC, yeah, or CA. So you just need to take the moment at point B equals 0, and then this FCA will create clockwise, so it's minus FCA or FAC, let's call it, to make it similar to the way it's pronounced in the question, AC, and times the distance, the horizontal distance, which is in this case 150, right? It's 150, right? And then this will create counterclockwise 3 kilonewton times this distance, right? Which is, I guess, it's around 600, 450 time 450 plus 150, so it's 600, and then that's it. Yeah, that's it, equals 0. And then you cancel it out, you get 4 here, so your FAC will be equals to 12 kilonewton, right? Yeah, so since this is positive, means that our assumption is correct. Means that if you draw the, oops, sorry, if you draw the hydraulic here, so the hydraulic will be like this, right? So means that they are in tension. Yeah, so this one 12, and they are in tension. So one of them is in compression, the hydraulic DE, and the hydraulic AC will be in tension. Okay, the hydraulic system, yeah. Of course, not the oil. The oil inside the hydraulic will always work in compression, because that's how hydraulic works. The by compressing the fluid inside it. But as a structure, the cylinder will experience tension for hydraulic system AC, and for hydraulic system DE, it's in compression. Okay, so it's pretty simple. The idea is that try to analyze as a whole first if you can. It's always good, yeah, even though you cannot get everything maybe from the global structure, global free body diagram, but even if you can get like part of it, it's always good. And then try to dismember and start with the member that has unknown less than 3, or at least maximum 3, and then you can start solving it, because you have 3 equations in general: sigma fx equals 0, sigma fy equals 0, sigma moment equals 0. Yeah, so for each structure that you're analyzing, you can solve at maximum 3 unknowns. Yeah, so make sure you work with the member that has least unknown from the beginning, and then you start move to the next more complicated structures. Okay, I hope it's clear for you. It's very easy, right? I don't spend like a whole 45 minutes. I guess like only 20 minutes or so. Okay, see you in the next questions. Bye.